Today I will be reviewing the logical functions and formulas in Excel, which are a little bit more advanced than the other formulas we've been looking at, but especially useful if you're doing any type of modeling work or anything that really relies on certain types of information being displayed so that you can change what the output is based on different logical statements. And so the way that logical formulas work is something called Boolean logic, which heavily relies on true and false statements. So essentially you're going to be putting in logical statements that would result in either a true or a false, and those true and false situations will dictate what Excel outputs. So for example, when you want to see if two cells are equal to each other, if they are equal to each other, then it would be a true, and if not, then it would be a false. So there's usually two results, either a true or a false, that the statement could result in, and Excel will know based on what you tell it what it should do given those situations. So you'll see here I have an example data table with some employee information. It's all made up, but just an example of a way that you could use it with a data table. There's also a sum range in top right that I'll be using in a few minutes. Comparison operators in the bottom right that are basically the way that you'll be structuring these logical statements. You can use the equal sign to compare things whether they're the same. Less than or greater than, or less than or equal to, and greater than or equal to are useful for number comparisons. And not equal to is kind of a weird one, so you should note how that looks. But when you want to see if something's not equal to a certain value, that's what you would use. So the first function is not really a function, but it's more of just a direct comparison. It's showing you what a logical statement would look like. So I'm going to click into the cell C89, and you can see that in there I already have a formula for a direct comparison. So to the right here I have some input variables, which would be the employee ID. And depending on what I put in here, I've got a formula, an HLOOKUP formula, which will go into the table. It'll look up employee ID 501, and it'll give me the office number for that employee. So in the F column, I've put just a direct reference to that exact office number. So these are the two related cells that we'll be comparing in our direct comparison here. And if I change this variable here, you'll see that to the right, the related cell 1 will change because it has a formula in it, whereas C2 or cell 2 is just a direct reference. So in this cell, I'll just delete it and I'll recreate this formula. So a direct comparison, we want to see if related cell 1 and related cell 2 are the same. So I just put an equal sign to say this is the start of my formula. I'm going to click on the first cell, E89, and then another equal sign, related cell 2. And this is basically saying the formula to the right of the first equal sign is basically, does E89 equal F89? So this will either output a true if it is true, or a false if they do not match. And you can see that they do match, and so it does output true. Like I just said, if I change this to 334 and I hit enter, you'll see that that changes to false. So this is good if you have things that are changing frequently and you want to compare two cells to see if they match. Another good way of doing this is using conditional formatting. So these direct comparisons are very useful for that. If you went to the conditional formatting bar, I actually made my own custom area with the formulas and functions and application pieces that I use the most of. But if you go to where your conditional formatting is, and you go to highlight cell rules and click equal to, I can do cells that are equal to true and fill them with green, let's say. And I hit OK. And now when I change this formula here, or this variable, you'll see that the highlighting goes away. If I put 501 back in, it'll highlight true. So if you're doing some error checking, this can be especially useful, because if you have, let's say, totals that are summing in one area, and then you also have that being referenced on another sheet, you can check whether the total equals another cell that you're referencing. And since these two should be the same, you want to highlight it only if they're not the same. And that's really good for error checking, because you can highlight rows or columns that don't match what they should be matching using that conditional formatting, and it can jump out right at you when you've made a mistake. So the direct comparison one can be also useful for using those comparison operators to the right. If I change this to row number here to 4 to get the age, and I will grab Nancy's age as well. And so here we're using the age now. So Steve is 34 and Nancy is 39. So Here I'm going to actually check whether related cell 1 is less than related cell 2. And you'll see that it comes up with true. So these direct comparisons are going to be very useful for putting them inside of different logical functions, because a lot of times like an if statement or and statement will require a logical statement within it. So you'll be putting these type of direct comparisons usually in those statements. So that brings us to the if statement, which is really probably one of the most useful functions in Excel. There's the ability to nest if statements within each other, so you can have multiple layers of if statements, which gets pretty complicated but can be very useful for making some super formulas. If you take a look at what I have written in the cell, I'm comparing E90 and F90, which are the C200 and F101 from the related cell 1 and 2. And the formula I have in here is checking to see whether it's a match and outputting match if it is and no match if it isn't. But I will just recreate that formula real quick from scratch so you can see how it's done. So the if statement, if you look at the syntax there, it says logical test. So this will be the logical statement we want to see if it is correct. So I'm going to do a direct comparison to see if related cell 1 equals related cell 2. Then you put a comma. It says the value of true. So this is what's going to, if those two are equal, this is what it's going to output. I can put, I had it as match before, but I'll just write correct. And then the value if false, no match. And anything you want to come out as text, you have to put it in quotes. If you wanted it to output a number or a sum or whatever, you can put whatever kind of value you want in there. This is just to show you how it works. So I'll end that parenthesis and then close it. So you can see that since this HLOOKUP is looking up input variable 334 and this cell is just referring directly to F101, these cells do not match. But if I change this to be 29, so it looks up John's office number, you'll see that it comes up with correct. And again, you could use another conditional formatting similar to what we did above to make it highlight something special when it says correct or no match or whatever it is that you need to do. You can also do conditional formatting on number ranges, and there's all sorts of additional advanced conditional formatting that I'll be showing you in a separate video. So that if statement is very powerful. You can use it to check whether things are equal to each other, less than. You can put a lot of logical statements into one formula and then have it output a certain value if it is. Another example of how this could be used is, let's say you have a list of products and then you want a formula that will put the applicable product rate or product price. So let's say you had two different products. You could say if it equals product 1, then use this price. If it equals product 2, or I mean, if it doesn't equal product 1, you could have it do something else, or you could have it look up into a list of products and return the value. So there's all sorts of different uses where you can have one formula that really does quite a bit of work. Frequently used within an if statement would be some of the other logical functions, like the AND function, the OR function. Those are really typically used within an if statement, but they can also be used separately. So here I'm comparing in my AND statement. I'm seeing whether from the top two rows, whether related cell 1 equals related cell 2 in both cases, in the direct comparison and the if statement rows. So I'll just quickly recreate this formula. So AND, basically you just feed the AND statement a bunch of logical formulas in between commas, and it will tell you whether all of these are true. If only one of them even is false, it'll come up with false. So AND really wants to make sure that every logical statement you put into it comes back as true. So if I put related cell 1 and related cell 2 from the first row, comma, related cell 1 and related cell 2 from the second row. So I just want to see, do both of these formulas result in equal values? The OR statement is very similar to AND, and let me just finish up the AND by showing if they are actually equal. So we had Nancy's age here, so I'll put in 334 so that they both come up as being equal, and you'll see that the AND statement comes up with true. You could also take the format from the direct comparison formula. If you go to the format painter and you put it on this AND one, you'll see that it comes up with true, and it highlights it in green because it took the conditional formatting and painted it onto this cell as well. So again, that was using the format painter, so I'll do it to OR as well. OR is similar to AND, except it will only result in true if any one of them is true, and it will only result in false if all of the statements are false. So you'll see here if I change this to 501, and becomes false because they're not all correct, but or still remains true because the second one is they still have a match. So if I also change this to 501, the or will come up with false because now neither of the two comparisons result in a true value. And you would use if you need a bunch of things to all be correct. So you need, let's say, to wear or to bring an umbrella outside, you need to be, first logical statement would be, am I leaving the house? And then second one could be, is it raining outside? And basically if those are both true, then you would need to bring an umbrella. Or you could use the or statement if, let's say, you're going outside already, and then either if it is raining or if it's snowing, you'd want to bring an umbrella, let's say. So if either one of those were true, you would want to go and take that. It's not really an Excel example, but it's just a logical format. Most of the if statements are structured as if something, so logical statement, then what you want to happen if that's true, and then there's else, which is the false side, and what you want to happen if it's not true. So another real life example would be if someone is over the age of 35, then they could run for president, else or otherwise they cannot. So really all these formulas are about is looking at these logical statements. So the better you get at compiling logical statements and figuring out how to use them effectively, you can really start broadening your abilities with Excel. And as always, I'm not necessarily showing in these level 1 examples any sort of real life application as much, but hopefully in future versions and more advanced lessons I will be able to show you how you can use this in specific examples. But right now I just want to teach you the tools so that you can figure out how to use them in ways that might help you in what you need to do. Not is a formula that it's kind of counterintuitive, but it'll basically make sure that what you're putting in there is not correct. So if I'm looking at E89 and F89, right now they are not correct. So if those two match, which they don't, so it outputs a false for whether these two match, but the not is checking the opposite, so it actually outputs a true if that's false. So it's checking to make sure this is not the case. So it is true that this is not the case, meaning that they do not equal each other. I don't use that as one as much because it's kind of confusing, and you can do it in the other way basically to make sure things are true, but it can be useful in some instances. A great formula is if error, which will basically make sure that the formula that you put into it, if it ever results in an error, what it should do in that case. So right now I currently have it, the formula is set up as if error, and then you put the value, which is what you want it to output, but then you put a comma, and if there's an error, this is what it should output instead. So right now I have it summing the sum range on the right, which sums to 215, but if there's any error with that formula, I want it to output error, you fool, and so I put that in quotes, so it's text. Currently there's no problem with the sum, so it's just outputting 215, but if I put in an error, so if you just do NA with a parentheses with nothing in between it, it'll put out an error. And then over here you can see that this changed to be error, you fool, because it can't add an error cell. So that can be very helpful if people are manipulating spreadsheets and you want to make sure that if something results in an error that it doesn't necessarily break, it might just be able to flag something for you so that you can go in and see what's wrong. And last but not least, these aren't really necessarily functions, but technically they don't require an argument within the parentheses, but it'll just output true if you put the true function in there and false if you do false. So this is really an instance kind of like where I just put that error over here. I just did equals NA with an empty parentheses, and that spit out an error. These would spit out a true or a false if you want to put that into a certain cell. So you can also do that without using the parentheses at all. If you just write true, it'll come out as true, and false, that'll be false. You want to make sure that whenever you're using a true or false, you don't necessarily put the true or false in quotes, because then it'll view it as text and not the true or false as in the logical sense. So I hope that was helpful.